So we're going to look at the graphs of f, f prime, and f double prime and look at them graphically and then determine some different questions that are being asked. All right. So this is really about reading graphs. And then we're going to also look at something else. We're going to go back and look at velocity, acceleration, and position functions. Okay. So that's what we're going to do today. So here's the graph of f. This is the graph of f. Okay. And so use the graph of f to estimate where the graph of f prime is 0, positive, and negative. So let's start on f prime. Where is f prime? Where is it 0? So I'm going to write here f prime of x equals 0. Okay, so where is that going to happen? To look for this, we're looking for horizontal tangents. So it looks like there's one right here at x equals -2, right here at x equals 0, and then also over here at x equals 2. Okay, so I would say, estimating this, I would say x equals -2, x equals 0, and then also x equals 2. So where's f prime positive? Okay, so f prime of x is greater than 0. Okay, so we would know f prime is greater than 0 when the function is increasing, because therefore the slopes would all be positive. Now this is a little bit different than asking where it's increasing, okay? Because we want to know where it's positive. So the derivative would not be positive at -2, and it wouldn't be positive at 0, but everywhere in between, any point on here would have a tangent slope that's positive, okay? And then same thing after 2 here. So for f prime of x to be greater than 0, we'd be looking at the interval -2 to 0. Looking at that, and again, not including -2, because I'm asking for where the derivative is positive, not where it's increasing, not where the function's increasing. If I was asking for where the function was increasing, I would include this point and this point. And then from 2 to infinity. Okay, because in here, any tangent slope, any point on to the right of 2, bigger than 2, would have a tangent slope that's positive. Okay, and so then we also want to look, where is it negative? Okay, so f prime of x is less than 0. Okay, so that we'd be kind of looking at where it's decreasing. Okay, so it would be all of these points in here would have a tangent slope that would be negative, and then also in here between 0 and 2. So we would, to answer this one, we'd say negative infinity to -2, not including -2, because we're looking specifically where it's negative. Okay, and then also from 0 to 2, and again, not including them. All right, so you can just list the intervals where this happens. Okay, let's go to the next question. So use the graph of f to estimate where the graph of f double prime is 0, positive, and negative. Okay, so where it's 0 would be where it's changing concavity, because remember f double prime is telling us concavity. So we're looking for inflection points, basically. All right, and if you look at this, okay, definitely this is concave down, and these are really hard to determine. Okay, so just know, like, there's a big swath of numbers that would be acceptable. Okay, because it's really hard, but definitely right in here it's concave down, and then in here, right in here, concave up. And I'm looking, it looks like right about here, right about x equals -1, all of this is concave up, and from here, and then you're looking at this, and I would say probably right about here at 1 also. Okay, I would say it changes concavity right now. I would say probably anywhere in between here and here, you could call that's an inflection point. Okay, because again, it's really, really hard to read these off of a graph. Min, max, sure, easy to see. Horizontal tangents, sure. Inflection points, really hard. Okay, so like definitely like right in here to probably right in here, I can tell it's somewhere in there. All right. Okay, so don't if you're a little bit off from the homework when you answer this one, don't get upset with yourself. Okay, it's very, very difficult to narrow down where it's happening. Okay, so right there, the second derivative, because it's changing from being positive to negative, it would have to be 0. To change from being positive to being negative, you got to cross through 0. So that would mean the second derivative is 0 right there at x equals -1. Okay, so f double prime of x equals 0. And I would say this happens at x equals -1 and at x equals 1. And then where it's positive, that'd be concave up. So f double prime of x is greater than 0. Okay, again, we're looking for concave up. You might want to write concave up next to this. Okay, so concave up, I would say -infinity to -1. All right, now I'm not asking for where it's concave up. I'm asking where the second derivative is positive. So we would answer this with -infinity up to -1, but we wouldn't include -1. However, if I was asking for concavity, we would include -1. Okay, and then also here from 1 to infinity, it's concave up. So then 1 to infinity. And again, we're not including 1 because it's 0 there. And I'm not asking for where it's concave up. I'm just asking for where the second derivative is positive. Okay? We use concavity to help us answer these questions. All right? We use concavity to help us answer where the second derivative is positive and negative. And we use where the second derivative is positive and negative to determine concavity, but they're not the same intervals necessarily, okay? I just want to keep iterating that because that's important, okay? So where is it negative, all right? So we'd be looking for where it's concave down, and that looks like between -1 and 1, okay? But since there's 0 there, it's not negative, okay? So that's another reason. We've already said that that's where it's 0. So f double prime of x is less than 0, meaning negative, okay? And I would call this -1 to 1. All right? Okay, so for this next example, okay, the graph of f prime is shown below. All right, so we're looking at this, okay, and we need to realize this is not the graph of f, but the graph of f prime, okay? So the graph of the derivative of the function f on the interval -4 to 4 is shown above, okay? Answer the questions about f, justifying each answer with information obtained from the graph of f prime. So all of our justifications have to come from explaining f prime, okay? So on what intervals is f increasing? Okay, so we're looking for where the derivative is positive, okay? So it's positive from -infinity to -2. It's not positive at -2, but just after -2 is positive. So that means it's continuing to be increasing even at -2, all right? So we're gonna stop increasing at 1. That's the last point where it's increasing, okay? So we would say that f is increasing on, and we'd start from -infinity and go all the way to 1. It's not two separate intervals because it's increasing before -2 and after -2 because the derivative is positive. So we're going to go -infinity all the way to 1, and that's where it's going to stop increasing, okay? And here's how I know this. It's because f prime of x is positive, so greater than 0, on what intervals? And we would say from -infinity to -2, parenthesis, union, -2 to 1, parenthesis. Okay, and that would be the justification. We're stating the reason based on the graph of f prime, okay? So on what intervals is the graph of f concave up? So to read concave up, remember concavity is the second derivative, and the second derivative is one derivative away from this, right? So f prime, right? So one derivative away. So we're going to be looking where is this increasing and decreasing to determine concavity, okay? So f prime is actually f double prime. And so we would be looking where is f prime, and for concave up, we'd be looking for where f prime is increasing, okay? So f prime is increasing, okay, to determine the concave up, all right? So where is it increasing? Well, it's not increasing in, f prime is not increasing here. It is increasing from -2 to 0, and then from 3 to 4. So it's increasing right in here, and it's increasing right in here, okay? So that would mean f is concave up. Okay, concave up on the interval -2 to 0. Now we're talking about concavity, so that's why I'm including it. -2 to 0, including, and also 3 to 4. So union, bracket, 3 to 4. Because f prime is increasing on those exact same intervals, okay? So f prime is increasing on the intervals -2 to 0, union 3 to 4. Okay. Now, we would not include -2 and 0 and 3 if I was asking you where f double prime was positive, okay? Because it wouldn't be there, okay? All right? So for part C, at which x coordinate does f have a local extrema? So that's local min and local maximum. All right, so we want to see where does f prime change signs, right? That's the first derivative test. Where does it change signs? Well, it's positive before -2, it's 0 at -2, then it's positive after that. So that's not a relative extrema. And then at 1, just before 1, it's positive, and then right after it, it's negative. And so that's the only one where it changes signs. And it's changing from being positive to negative. So the function is increasing and then decreasing. So if it's increasing and then decreasing, we would have a local or relative maximum there, okay? So f has a local maximum. And we don't know what it is, so we can't say a local maximum of this, okay? And remember, local is also relative, okay? So f has a local maximum at x equals 1 because, and again, we have to refer it to this, because f prime changes from positive to negative at x equals 1, okay? So every justification, when they give you the graph of f prime, every justification has to be in reference to the graph of f prime, okay? What is it about the graph of f prime that's telling you this, okay? So what are the x coordinates of all inflection points of the graph of f? So to find inflection points, okay, I have to look at f double prime, but f double prime is really the derivative of this, and one derivative away is increasing and decreasing. Two derivatives away from something tells us the concavity of it. One derivative away, and so the second derivative is one derivative away from the graph of this. Okay, hopefully that kind of makes sense. All right. So we're looking for where it's changing from either increasing to decreasing or decreasing to increasing. So here we're increasing, or sorry, we're decreasing and then we're increasing. So that means f, the derivative of this would be negative and then positive. But the derivative of this right, since this is f prime, is the second derivative. So this is right in here. This is telling me the derivative is negative, and then the second derivative is negative, and then the second derivative is positive here. So we have an inflection point at x equals -2. And then we have another one at x equals 0, okay, because we're changing from increasing to decreasing, okay? And then also at 3. So we got to talk about why it's happening there, okay? So f has inflection points at x equals -2, comma, x equals 0, comma, and then x equals 3. Because f prime changes from decreasing to increasing at, okay, so it's changing from decreasing to increasing at x equals -2. And it's also doing the same thing. It's changing from decreasing to increasing at x equals 3. So at x equals -2 and x equals 3. And because this might be a run-on sentence, okay? And because f prime changes from increasing to decreasing at x equals 0, okay? You could say this with 3 separate sentences. Okay, that's really clear and easy to read. I'm just telling you, okay? And then you can also combine, if they're changing the same way, you can group them together, okay? So you could do this with 3 sentences, each one individually. You could do it with 2 sentences, one where you're talking about the ones that change from decreasing to increasing, and then the second sentence would be the one that's changing from increasing to decreasing. Or like I did it all in one long, lengthy sentence, okay? The longer the sentence, sometimes the more complex and harder it is to read, okay? That's why I added and because I kind of restated it again, just to help make it really clear to whoever's reading it, okay? So now we're going to jump into something kind of completely different, all right? But we're going to go back and talk about particle motion. So just know everything I'm doing, I'm actually, you wonder like, when are you going to review for your final? I'm doing it right now with these problems, okay? All right, so a particle is moving along the x-axis with position function. So this is my position function. T is greater than or equal to 0. So this is I want to state this, okay? This is a left endpoint. We don't have a right endpoint, but we do have a left endpoint. Okay, so what that means is that the domain would be something like this: a bracket 0, comma, infinity. Okay, so we have a left endpoint. We don't have a right endpoint. Okay, that's going to play into this as we turn the next page and answer some problems. Okay. All right, so the very first thing is I want to find the velocity function for t greater than or equal to 0, okay? Now, I want to say this because this is going to happen on your final, okay? What I'm giving you is x of t. So if I ask you for the velocity on a free response question, you have to say how this is related to what the stem of the question. And the stem of the question is x of t. So what I'm trying to get at is you have to write this. And I've seen it where you don't get points for the free response because you didn't refer back to how do you get the velocity from what was given to you. So we would say something like this. Okay, so x prime of t, all right, is equal to, all right, v of t, which is equal to, and then you could say, all right, so now we can do it. So this would be 6t squared minus 28t plus 22. Okay, and because the derivative of negative 5 is just 0. All right. So I know it doesn't, we did that, okay? We found the velocity. Let's do the acceleration. So again, to find the acceleration, we got to refer back to this. So this would be x double prime of t, which is equal to v prime of t, which I don't think you'd have to do that, okay? Which is equal to a of t. And that would make this one 12t minus 28. Okay. Now, you're going to understand when I turn the page. I also want to do here is I want to find the critical values, okay? Because that's going to tell me a lot about this particle, okay? Where it is stopped, where it's moving right, where it's moving left, because we're moving along the x-axis. So we're definitely moving right and left, okay? And so when the velocity is positive, we're moving right. When the velocity is negative, we're moving left, okay? All right, so we want to find the critical values. So that would be x prime of t is equal to 0. So that'd be 6t squared minus 28t plus 22 equals 0. Okay, and then you can factor out a 2 because all of these are even. That's the biggest number you could factor out. So 2 times, and then 3t squared minus 14t plus 11 equals 0. So you could do an area model. So I'm going to do it down here. Okay, we're looking for a product of 33. And sum would be equal to negative 14. I'm just making a small one to do it here, okay? So this would be 3t squared, and this would be 11. So product has to be 33, and sum would have to be negative 14. So that would be negative 11 and negative 3. So this would be negative 11t, and this would be negative 3t. Okay, so then GCF across here would be t, and that would make this one 3t. And then this would have to be, to make 3t become negative 3t, we'd have a negative 1. And then t times negative 11 would give you the negative 11t. And then just double check, negative 11 times negative 1 is positive 11. So that makes this factor into 2 times 3t minus 11, and then t minus 1 equals 0, which means t would equal 11 thirds, and t would equal 1. And both of those are in our domain, okay? So now we're going to do intervals. And we're going to start at 0. 0 to the first one, which would be 1. And then 1 to 11 thirds. And then 11 thirds to infinity. Okay? And then we're going to look at a test point. So right here, I would choose something like x equals 0.5. I would pick a number that's divisible by 3 that's less than 11. So like 10 thirds isn't divisible by 3, but 9 thirds is, right? So 9 thirds is smaller than 11 thirds. And so we want to be somewhere in between 3 thirds, which is 1, and 11 thirds. So 9 thirds does it, right? So you know what? And I actually put x, and we should have put t, because we're actually putting t values in. That's like a spelling error. It's understandable, okay? So 9 thirds is 3, so we're going to use t equals 3. And then we need to be bigger than 11 thirds, and something divisible by 3, so something, 12 thirds, so that would be t equals 4. Okay, and then we're looking at the sign of v of t, the velocity, right? So if we put it in here, okay, this 2 is always going to be positive, okay? So the first factor is positive. And then if we put 0.5 in here, 3 times 0.5, that's going to give you a number that's smaller than 11, right? So it's going to give you like 1.5 minus 11. That's definitely going to be negative. And then 0.5 minus 1, that's going to be negative. So I have a positive times a negative, which is negative times negative, and that would be positive. Okay, so what is that telling me about the behavior? That behavior, because the velocity is positive, that tells me the particle is moving right. And so then t equals 3, so 2 is always going to be positive. 3 times 3 is 9, so that's, and then minus 11, that's still going to be negative. And then 3 minus 1, that one's going to be positive. So a positive times a negative is a negative, and then negative times positive is negative. And so we're moving, on this interval, we're moving left. And then when t equals 4, the first one is always positive because it's 2. And 3 times 4 is 12, and then minus 11, so that's going to be positive. And then 4 minus 1, that's going to be positive. So you're multiplying 3 positives, so that's going to be positive. So now we're moving back to the right. Okay, so we're moving right, then we're moving left, and then we're moving right again. Okay. All right, so you're gonna see why in a minute why I'm doing this. Okay, you may be like, why? You didn't even ask for that, right? You're gonna see in a minute. Okay. All right, so now I want to do the same thing but with acceleration, because we're gonna look at combinations. Remember this? Where is the velocity and acceleration, both positive, both negative, and so on. Okay. So, all right, to do this, we're going to set it a of t, or x double prime, because that would be a of t, equal to 0. So that'd be 12t minus 28 equals 0. So that'd be 12t equals 28, which means t is equal to 28 twelfths. And that would, 7, no, not 7, 4. 4 goes into both, sorry. So that's going to be 7 over 3. Okay, so our intervals for this one are going to, again, because it's the domain, right? 0 to 7/3, and then 7/3 to infinity. Okay, and a test point, a good test point in here would be 6/3, and 6/3 is really just 2. And a good one in here would be 9/3, and 9/3 would be 3. And so we're looking at the sign of the acceleration. And so when we put 2 in here, right, when we put 2 into this, into a of t, we get 12 times 2 is 24, and then minus 28. So that'd be negative. And then when we put 3 in here, 12 times 3 is 36, minus 28, that'd be positive. Now, unlike velocity, where we're moving right and left, the sign of the acceleration doesn't really tell us anything by itself, okay? So now what I taught you before is to do a number line, okay? You remember doing a number line? And then that's gonna help us determine stuff, okay? So we want all of these critical values, and we're gonna go to infinity here, okay? So the critical values are 11/3, 1, and 7/3. And remember, 1 is really 6/3, or it's not 6/3, 3/3, right? So that's, of these 3, that's the first one, okay? So 3/3, which is 1. So let's put that 1 there. Okay, and then the next one is 7/3. And then 11/3. And then we have infinity out here, okay? So what do we know from 0 to 1? We know v of t is positive. So v of t, and I just realized you guys can't see it. Okay, so let me give you a chance to copy that. So right here, v of t from 0 to 1, we can tell, slide it up a little bit. From 0 to 1, the velocity is positive. So v of t is greater than 0. From 1 to 7/3, okay, so 7/3, v of t is going to be 11/3. Actually, it's V of t, sorry, V of t is going to be negative for both of these, right? Because it's 1 to 11 thirds. So 1 to 11 thirds. So we know that V of t is less than 0 here and here and even at 7 thirds, okay? So it's expanding that whole interval right there, okay? And then from 11 thirds on, we know V of t is greater than 0. So, okay, so how about for the acceleration? Okay, so from 0 to 7 thirds, so both of these, the acceleration is negative. So A of t is less than 0, and here A of t is less than 0, and these are spanning that one, right? They actually go from here to all the way to here, okay? And then 7 thirds to infinity, so both of these, we know the acceleration is now positive. Okay, so A of t is greater than 0, and right here A of t is greater than 0, and it's actually spanning it. So it's going across the 11 thirds, my point is, and it keeps going this way, right? Forever. Okay, so when it's the same sign, we're speeding up. When they're opposite signs, we're slowing down. And that makes sense because the velocity is 0 at t equals 1. So we're stopping. And to stop, you have to slow down, right? To stop, you have to slow down. Okay, so we're slowing down here, we're stopping, okay, and then we're speeding up, and then we're slowing down from 7 thirds to 11 thirds. We're slowing down because they're opposite signs, okay. And then at 11 thirds, yeah, look, the velocity is 0 at 11 thirds. So we've stopped at 11 thirds, and then what do? We speed up from there on out, okay? All right, so let's use this to answer some questions on the next page. And I'm gonna refer back. I'm gonna go back and forth and bring this back. Okay, so the very first question, and this is describe the motion of the particle. What is the initial position of the particle, okay? So the initial position of the particle, okay, would be x of 0. So the position at time 0. So that would be, and let me write this. Remember, x of t is equal to 2t cubed minus 14t squared plus 22t minus 5, and t is greater than or equal to 0. So this is going to be 0, this is going to be 0, this is going to be 0. So we're left with -5. Okay, so the initial position is -5 on the x-axis. Okay. So that's where we're starting at. We're starting at x equals -5. Okay. So when does the particle stop? Well, how do we know when it stopped? That's when v of t is equal to 0. Okay. So v of t is equal to 0. We solve that, right? Back on the first page, right? We solved where is v of t or x prime of t equal to 0, and we found it at 11 thirds and also at 1. So the particle stops at t equals 1 and t equals 11 thirds. And we need to give a reason. So it's because v of 1 is equal to 0 and v of 11 thirds is also equal to 0. Okay. So you could also say because v of t is equal to 0 at t equals 1 and t equals 11 thirds, and that'd be perfectly fine. Okay. So here, we're going to use that sign chart that we created on the first page to answer this next question, okay? When is the particle moving left and when is it moving right? Okay, so at 0, okay, at 0, the velocity is actually 22. So that's positive, right? Okay, so at time 0, it's actually moving right because v of 0 is equal to 22. Okay, so I'm going to write this. V of 0 is equal to 22, and it's positive. And the interval from 0 to 1, it's positive, but at 1, it's not positive. The velocity is 0 there, right? So it's only moving to the right from 0 to 1, including 0, but not including 1, okay? Because the velocity is 0 at 1. Okay, so the particle is moving right on the interval 0 to 1, not including 1, and also 11/3, but not including 11/3. So union, parenthesis, 11/3, comma, infinity. And we're not including 11/3 because the velocity isn't positive there. So it's not moving right at t equals 11/3, okay? And so we'd say because v of t is greater than 0 on those exact intervals, 0 to 1, union 11/3 to infinity, period. And then we need to talk about moving left. So the particle, we know it's the particle's moving left when the velocity is negative. It's not negative at 1 and it's not negative at 11/3. So we're not going to include either one. This is the only interval in which the particle is moving left. Okay? So the particle is moving left on 1 to 11/3 because v of t is less than 0, meaning negative, on 1 to 11/3, period. All right, let's go to the next one. So next what we want to do is we want to find when is the particle speeding up, all right, and slowing down. So let's do the speeding up first, okay? So it wasn't speeding up here, it is speeding up here, okay? And there's a change in the acceleration at 7/3, right? Because that's one of the critical values for the acceleration. So it is speeding up from 1 to 7/3, okay? And we don't include either one because the velocity isn't negative at 1, because 0. And also we don't include 7/3 because that's where the acceleration is 0. So everything in between 1 and 7/3, it's speeding up. And then over here from 11/3 to infinity, it's also speeding up, okay? So we would say the particle is speeding up on the interval 1 to 7/3 and then union 11/3 to infinity because v of t is greater than 0, I'm sorry, less than 0, and a of t is less than 0 on the interval 1 to 7/3, and v of t is greater than 0 and a of t is greater than 0 on 11/3 to infinity. All right. And then, okay, when is the particle slowing down? So the particle is slowing down from 0 to 1. Okay, so the acceleration is negative. Okay, so a of 0 is negative 28. And we know v of 0 is 22. So even at 0, it's slowing down because they're opposite signs, okay? So I gave specifically how on each individual interval, what's happening, okay? But you could also say they're opposite signs or they're the same sign, okay? So the particle, I'm gonna write it that way for this next one, okay? So the particle is slowing down on 0 to 1, but not including 1. All right. And also 7/3 to 11/3 because they're the opposite signs there too. Okay. Union, and then we would say 7/3, comma 11/3, parenthesis. Okay. Because, and this is what we would say, V of t and A of t are opposite signs on 0 to 1, and then union 7/3 to 11/3. Okay, so then there's one more thing I want to talk about, and that is this. When is the particle moving away from the origin? Okay, so we know the particle is moving away, okay, and moving towards. So moving away, I'm just going to talk about, we're not going to actually do this one just for the sake of time, okay? So moving away, you could do that 2 different ways, okay? So this is equivalent to like speeding up and slowing down, but it's for position and velocity. So you're moving away if you're on the left side, and you'd be moving left. You'd have to, if you're on the left side and you're moving left, you're moving away. And also if you're on the right side, moving right. Okay, so left side would, your position x of t, to be on the left side, x of t would have to be less than 0. And moving left, your v of t would also have to be less than 0. And then we could also do this by being on the right side and moving to the right. Okay, so right side moving right, that would be x of t would have to be greater than 0 to be on the right hand side, and moving right, your v of t would have to be greater than 0. Okay, and then moving towards, I think I'm going to write it a little bit differently than I did right here. Okay, so moving towards, we could do that by being on the left side. Okay, so left side. And to be on the left side, that would mean x of t is less than 0. And if you're on the left side and you're moving right, you're moving towards the origin. Okay, so then moving right, and to be moving right, v of t would have to be positive. So one of the reasons I'm not doing this is because we would have to solve the position function graphically. Okay, but I do still want to go over like how you do this. Okay, so there's another way you can be moving towards. You could be on the right side. And so then your position function, x of t, would be greater than 0. And then okay, so if you're on the right side to be moving towards the origin, you'd have to be moving left, which would mean v of t is less than 0. Okay, so you could overlay on top of each other. And let me show you really quickly. Okay, this is an overlay, okay, of the position. The position is the blue function because it's a cubic, and the velocity function is green. So right here, my position is negative, but my velocity is positive for this time interval right here. Okay, so right there, I know that I'm on the left side, but I'm moving right. So I'm moving towards the origin. Okay, then after that, from here to the next intercept, I see my position is now positive, but my velocity is positive. So that means I'm on the right side moving right. Now I'm moving away until this x-intercept right here, this time period right here. Okay, and then from this time period to this time period, I now see that my position is positive, so I'm on the right side, but now my velocity is negative. Okay, right there, my velocity is negative. So position positive, velocity negative, so I'm on the right-hand side, but I'm moving left. So that means I'm moving towards the origin on this interval right here. And then from this interval to this one, okay, both the position and the velocity are both negative. So that means I'm on the left side. I'm on the left side of the origin, and I'm moving left. So I'm moving away from the origin in this interval from this time to this time. And then from this time to this time right here, okay, I know my position, my position is negative. My velocity is going to be positive from there on out. So I'm on the left side moving right. I'm moving towards the origin. And then finally, my position from there on out, my position and my velocity are both positive. So that means I'm on the right side moving right. So I'm moving away from there on out. Okay, that's just a way to do it graphically. Okay. Okay, so this last question is this, and we are going to answer this one because this is asked often, okay? When is the particle furthest to the left? Furthest to the left on the x-axis would be an absolute minimum. Okay, and furthest to the right would be an absolute maximum. Now, here's what's hard. We don't have a closed interval. Okay, so we have to think about this a little bit. Okay, what's happening to the velocity? Okay, so furthest to the right, we are moving right. So from 11/3 on, we are moving to the right forever. So if you think about this, you keep moving right, so you're never going to be furthest to the right, because as soon as you pick one that's furthest to the right, go a little bit longer in your time and you're even further to the right. Well, now that one is it. Well, you keep going further and further. There's never going to be a furthest to the right. Okay. From basically this, from 11/3 on, the velocity is positive, which means it's moving right. So the particle will never be there. There's never a point where the particle is furthest to the left. That's what I'm trying to say. Sorry. Okay. All right. So we'd say there is never a point furthest to the right for the particle, or something similar to that. Okay, because it keeps moving to the right. And if it keeps moving, you're never furthest to the right. Okay, now, think about this. Okay, we're moving right, and then we're moving left. Okay, so the minimum, okay, could come at 11/3, but it also could have been at the end point at 0. So we need to find x of 0, okay, which we already have. And then we also need to find x of 11/3 and compare and see which one's the smallest. Now, why are you saying, you may be asking, like, why are you saying check the endpoint? Okay, so if we went right, okay, so if we started at a point and we went right, okay, and we didn't go, and we went left, but we didn't go as far left as we went right on this first interval, then that would mean this endpoint would have to be the minimum, okay? But if we start at a point, we go to the right, and then we go more left than we did right from the initial position, then that would mean we're further to the left than where we started initially, which means that now at 11/3 would be the minimum. So you can't tell just by looking at this, okay, by looking at the sign chart and all that, and determine where it is furthest to the left. You have to check the endpoint, and you have to check this critical value after you've moved to the left, which is at 11/3. So we need to find x of 0. And we already found that in the original problem. That's -5. And then we also need to find x at 11/3. Okay, because that's a critical value. You could do all the critical values. That wouldn't be wrong. You just don't need to. Okay, it's not necessary. Okay, so so I have my position function in y1, okay? So I'm gonna do alpha trace number 1, y1 of, and I'm gonna put a fraction bar, 11 thirds. And let's see what we get out of this. So we get negative 13.963. Okay, so that means we started at -5 and we went, and we did go at -5, we went to the right and then we went left, and we went more left than we did right because this is a bigger negative value, right? We went further to the left than -5, okay? All right, so the particle is furthest to the left at t equals 11 thirds, okay? So you could have done also x of 1, okay? And so if you did x of 1, if you also added that one, you just wouldn't have to. That's why I'm saying that, okay? If we did x of 1, then that would be 5, okay? So we started at -5. From 0 to 1, we moved all the way to 5. Now we're at position 5 on the x-axis. And then from 1 to 11 thirds, okay, we moved left, and then we wound up at negative 13.96. So this is kind of like the candidates test, other than it's not, we don't have a closed interval, okay? But you could check the critical values and kind of understand what's going on here, like we can't go furthest to the right, okay? So this would never have an absolute maximum. This would just have an absolute minimum, okay? Because it keeps the position function just keeps going up and up and up and up, okay? After 11 thirds. All right. Hopefully the discussion on absolute or not absolute particle motion is helpful. Okay. You're going to see stuff like this on your final. Okay. So this is one way of preparing for the finals by doing these problems. Okay.